Hi, good afternoon. This is the continuation of our report about Ohm's law and electrical power. So for today, we're going to discuss first Ohm's law. So what is Ohm's law? So first, it is introduced by George Simon Ohms and published in his 1827 paper, the galvanic circuit. So Ohm's law is the relationship between voltage, current, and resistance. Ohm's law states that the electrical current, which is represented by I, flowing is proportional to the voltage and inversely proportional to the resistance. Therefore, if the voltage increases, the current will also increase and resistance will decrease, or vice versa. So it is represented by the formula I is equals to V over R, wherein I represent as the electrical power, or the I is the current, voltage is the volts, R is resistance. So the unit measures of current is amps, or capital A, voltage, volts, or capital V. For the resistance, it is represented as ohm, or omega. So let's have sample problem. So problem number one, we have first, the current passing through as a resistor in a circuit is 0.01 ampere when the voltage across the same resistor is 5 volts. What current passes through this resistors when the voltage across it is 7.5? So first, we need to identify what are the given in the problem. So we have the current, which is 0.01 ampere, voltage, which is equals to 5 volts, and we need to find the resistance for I1, and we need also to find the I2 if V2, or voltage, or the second voltage is equals to 7.5. Now we're just going to substitute this to the problem, to the formula that we have. So we have for R1, we have R is equals to V over I, or resistance over current. So just substitute the given. So we have 5 volts over 0.01 ampere, which is equals to 500 omega, or 500 ohms. That is the R1, or the resistance. Now we're going to compute for the current 2, or the formula is I2 is equals to V2 over R, which is our V2 is equals to 7.5, and we're just going to use the resistance that we get from solving the first the resistance. Okay, so we have 7.5 volts over 500 ohms, or omega, and it is equals to 0.015 ampere. Now we got the current if the voltage is equivalent to 7.5 volts. So we have the second problem. Second problem is a small light bulb is connected to a 6 volts battery and draw 2 amperes of current, or 2 amps of current. What is the net resistance of the bulb? So in this problem, we're just going to get the resistance if we have 6 volt battery and 2 amps of current. So first, what are the given? So volts is equals to 6 volts, current is 2 amperes, and we need to find for the resistance. Formula for resistance is equals, or R is equals to V over I. Just substitute to the given to our formula, which is R is equals to V over I, which is equivalent to 6 volts over 2 amperes, and it is equals to 3 ohms. Okay. Now we proceed to electrical power. Electrical power is the rate per unit time at which electrical energy is transferred by an electrical circuit. The SI unit of power is watts, or it is equivalent to 1 joule per seconds. In calculating power, law of conservation is being applied, wherein power supply is equivalent to power absorbed. So unit of measurements, power, the unit is watts, or capital W. For voltage, volts, or V. For current, we have amps, or capital A. Resistance, ohms, or omega. Now, we have this power triangle, wherein we can easily identify what is the formula we're going to use. If, for example, power is given, you just need to multiply the current to the voltage. And if the current is given, just divide power and voltage. And if voltage is given, just divide power and current. So that is the power triangle. We also have power triangle, or this kind of triangle in calculating ohms, or what they call the Ohm's law problems. We have also that kind of triangle. So problem number one. So calculate the voltage of an electric blanket that draws 9 ampere to transform 50 watts of energy. So we have our current is equivalent to 9 ampere, and for the power we have 50 watts. So we're going to find what is the volts of the electrical blanket. Just substitute the given to our formula, which is equals to V equals to I over P, which is equals to 9 amperes over 50 watts, or 0.18 volts. So that is the answer to our problem. And we have this table. You need to find the missing, or complete the missing field. So we have resistors, resistance, voltage, current, and power. There are some that voltage and current are given, so you need to find the resistance and power. And if the resistance and voltage is given, you need to find current and power. So this is our exercise for today. Thank you and good luck.